So, hi and welcome to everyone who has joined us tonight to talk about the revival of wild lake trout in Lake Champlain. We're fortunate to have Dr. Ellen Marsden of the University of Vermont join us tonight to talk about what she's learned and what others have been learning about lake trout in Lake Champlain. Since arriving in the region in 1996, Marsden has investigated the fate of the lake's trout, watching as a self-sustaining population of lake-borne trout have started to take hold in the nation's 13th largest freshwater lake. I wrote a story about this, the sort of the backstory of, what researchers have found. It's on in our latest magazine issue and on our website. And as I reported that story, anytime I asked someone a question that they didn't know the answer to, they said, I don't know, go ask Ellen. So we're fortunate to all have that chance tonight. When I was in the field with her this spring, she told me that after decades of trying to understand what was going wrong with the lake's top predator, as she now retires, she's asking what has gone right. So Ellen and I are going to get the discussion going, and in the second half of the hour, we'll open this up to questions from you all. When we get there, all you have to do is, click this raise hand function, and I should be able to, unmute you and you can ask your question. So thanks again for participating, Ellen. I appreciate your time. I appreciate everyone who's joined us tonight. So Ellen, let's start when you got to the region in the mid-1990s. When you came to UVM, what was the state of lake trout at that time? And what were the key questions that you were researching in those early years?
Lake trout were in the same position that they were in the Great Lakes, which is they'd been stocked for, in this case, almost 35 years at that point, with the state trying to restore them as a self-sustaining population, states, I should say, New York and Vermont. And basically stocking meant that there was an adult population that had come as juveniles from the hatchery, but that was it. There was nothing being produced naturally within the lake.
Right. And so just to sort of set the stage here, since the 1970s, or even going back further, I guess, there was obviously this native population of lake trout in the lake going back hundreds, probably thousands of years. By 1900, for a lot of different reasons, pollution, development, small fishery, reasons maybe we don't understand, the last native lake trout was pulled from the lake. And
Right.
so, in the 50s, 60s, really in the 70s, New York and Vermont started to get very serious about trying to, get a lake trout population back in Lake Champlain. And they've been, stocking tens of thousands, some years, well over 100,000
Yep.
lake trout into the lake every year. So sort of when you got here, what were some of the key questions in your mind that you were trying to understand about, why the lake trout, how they were doing and maybe why they weren't sort of producing in the lake themselves?
Well, I was following a sort of a course of theory and action that we'd been doing in the Great Lakes and continue to do, which is the first thing you say is, well, let's start at the very beginning of the life cycle. Is there good spawning substrate, good spawning sites? Fish have particular habitat needs when they spawn. In the case of lake trout, they want basically to bury their eggs, and I put that in quotes. I'll explain that. The same the way that salmon do. They want to hide their eggs in the substrate because they're going to incubate between November and April. So that's a long time where predators can get at them and wave action can stir them up and damage them. So, a parent protects its young. So they need rocky sites with clean interstitial spaces. Is there anything like that out there? Oh yeah, lots. In fact, we've added good spawning sites by building break walls and cribs and things like that. So then we ask, well, do the lake trout know they're there? They were raised in a hatchery. So we looked for places where lake trout assembled. Yes, they're finding those places. Well, are they spawning there? So we caught eggs. Yep, high densities of eggs at those sites. You just keep working through the life cycle. In spring, are those eggs hatching and producing the little fry, or what we call free embryos? Lots of them in lots of places all over the lake. Do they grow up? We get them for about 6 weeks after hatching, and that was the end. At that point, we see them getting bigger and sort of, wandering off the reefs the way they should, and never saw them again. We would try and sample for the juveniles or the adults that should have been growing up from wild fish. Nothing.
Right. So we knew that these, stocked fish were growing up, having, reproducing,
Right.
laying eggs. Those eggs were hatching, and we could
Right.
see these tiny fry basically swim away. And then
Yeah.
when you went to go look for them, at the end of, whatever that next spring after the winter to see had they
Right.
made it through the winter, we couldn't find anything.
Exactly.
Right.
You worry also a little bit is, are we looking with the right method? It's easy to find little tiny fry because we have a fry traps, their technique. Finding something by September when it's about this big is actually quite challenging. It's, again, they're very dispersed. So, is it possible we missed them? We weren't using the right method? And we'll go into the story a little bit more as we progress. But as far as we could tell, they weren't there. And we knew they did not grow up and become adults because they're all the stocked fish are tagged when they're stocked with a fin clip, so we can recognize the difference between a naturally produced fish and a stocked fish.
Right. And I mean, to that point, maybe it's a good time to talk about sort of definitions. You hear a lot of words thrown around. They're wild fish, they're native fish, they're, stocked fish. Talk about the differences. What's a native fish? What's a wild fish? What
Right.
is stocked fish?
And
And
then we
which
get into
is
terms
their
like
fin flip?
naturalized fish, which is even worse, right? I mean, a native fish basically simply says that it evolved here naturally, it got here and evolved here without any intervention from humans. Stocked is obviously the opposite of that, that humans at some point deliberately or sometimes accidentally, there are a lot of invasions that happen, like zebra mussels, for example, where something gets into a lake accidentally. But stocked, in this case, it's fish. It was deliberately introduced into the lake by state agencies to restore a population. So the stocked fish are still native. The species is native to the lake. But then we distinguish between, did it come from a hatchery or did it come from reproduction within the lake? And wild fish then was something that was actually spawned as an egg, hatched from that egg, and survived in the lake without ever seeing a hatchery.
Right. And when I go out there and if I'm fortunate enough to catch a lake trout, how am I going to know if it's stocked fish or a wild fish?
Great question. We want to be able to assess that, right? So every fish that goes into the lake from a hatchery has a mark in the form of a fin that's clipped off when it was about, yay big. And so they clip one of the five fins, one of the two pectoral fins, the forward ones, or the pelvic fins. They're like our arms and legs, or the adipose fin. And notice a question from Lewis in the chat there saying, "What's the purpose of the adipose fin?" And it's actually a hilarious question because for decades, centuries, in fact, we've clipped that fin. It's just a little tiny fin on the dorsum, thinking it doesn't do anything, a little tiny little bleb, and it's very easy to clip it off and mark a fish. It turns out that if you look at fish across all 35,000 species of fish, lots of fish have adipose fins, lots of species, all sorts of different, unrelated. It keeps cropping up in evolution. And I won't get into details, but basically it does have a role. It's like a trim tab. It helps a fish know whether it's swimming most efficiently by moving forward, beating its tail at the right rate. So it's a sensory organ. So if a fish has a clipped fin, it's from the hatchery. If it doesn't have any clipped fins, they're all intact. It's just possible it got missed because these are little tiny fish and about a 1% missing rate. Sometimes they can regrow and it's hard to tell. So we figure anything above about a 4% rate of unclipped fish, that's natural reproduction. Under that, maybe it's just error.
Right. Now, in 2015, you and colleagues did start to find these juvenile fish that were unclipped, wild fish that you had been looking for. Talk about that. What was that like when it started to dawn on you that you guys were seeing juvenile wild fish in the lake?
Well, anybody on the lake that day would have heard the screaming on the boat, I think. Joy, that is, absolutely. It really was a seriously incredible moment. We were working with Captain Steve Cluett, who I had worked with years back when he was captain in Lake Ontario with the state of New York. And he had been doing juvenile surveys for New York. he knew how to trawl for juvenile lake trout. We were having trouble, as I mentioned before, catching any little fish, stocked or otherwise. And I basically said, Steve, can you help us get little juvenile fish so we can assess them? He goes, I got that. We run a trawl using his protocols, and we bring up about, well, I don't know, 20 or 30 lake trout, of which about a third of them did not have a fin clip. It's like, whoa, what did you just do, Steve? Could you do that again? So he does it again, we get more. And it was amazing. About 20-25% of our catch that day was not just wild fish, but multiple ages of wild fish. So the trawls, in a trawl is just basically a big net you drag on the bottom, for about 10 minutes and catch anything that's in the way. And it mostly lake trout, smelt, alewife. But we were catching what we call 0-year-olds, fall fish, fish that had been born that year, 1-year-olds, 2-year-olds, and 3-year-olds. So this wasn't a fluke. We had 4 different years in which, at least 4 different years, and we couldn't have seen any older fish, in which they'd been successfully reproducing and what we call recruiting into the population. We knew all along they were successfully reproducing and producing fry, but they've got to survive through their first winter to know that, okay, now they're in the population, they've got it made, basically. And that's recruitment.
Right. So there's this, management cooperative with fisheries managers from New York and Vermont, U.S. Fish and Wildlife that are, sort of collectively meet and study and
Yeah.
make decisions about stocking levels. So what were they seeing after you guys started to see these wild fish? What were they looking at before they, in order to determine whether or not it was appropriate to cut stocking levels?
Right. I mean, this is what you're speaking to you said it, it's an incredible collaboration between all of the parties working on the lake. It's the federal agencies, it's the state agencies. Quebec's part of this collaborative, the university, the US Geological Survey, which is a research branch of the federal government. Basically all talking to each other on a regular basis and saying, what are you doing? Can we help? What do we do with this information? The concern was twofold. One is this just a fluke? Oh, it was just a few years of, yeah, maybe it won't continue. Maybe they won't survive. So the first thing was, how consistent is this? And so we kept trawling every year, and each year we were getting more and more ages, new year classes, new cohorts of young fish, and higher percentages. We got up to close to 60-70% of the catch was wild fish. But that only catches the juveniles. The thing the state did, state of Vermont, is okay, we'll go out and see if the adults now contain these wild fish. So they started gill netting. This was led by Bernie Pienka. They started gill netting, and sure enough, 10%, I think, in that first year were unclipped big fish. They're doing great. They're slowly aging into that adult population. That adult population eats, right? This is the top predator in the lake, along with walleye and Atlantic salmon. So you've got to start worrying, how many adult fish are we adding to the predator population while we're also stocking this at that point 85,000 every year. We could overstep the capacity of the forage base, the smelt and the alewife and the trout perch and the sculpin, to support this population. So yeah, there's a deep concern about, maybe we should pull back a little bit on how many we add, because nature's going to do what it does, and we can't stop that. And just while we're on it, the other problem you've got is something we call predatory inertia. If a lake trout is stocked in the lake, say as a 1-year-old, or it's hatched in the lake and it survives, you've got it for 20, 30, maybe even 40 years as a predator. You can't then say, oops, too many fish, and pull them back out again. So you've got to plan for decades into the future.
Right. So, I mean, how did as we started to see more of these wild fish and you're trying to balance what we're stocking, what is surviving in the lake, how did the research agenda start to evolve? Like what, new questions were you guys asking? Sort of what were you thinking about at that time, and sort of what were you and your students and postdocs looking into?
Great question. I mean, there were a number of questions. Keep in mind that the Great Lakes have been doing this for as longer, trying to find out why their stocking has not been yielding wild fish. There's been a couple of success stories. Lake Superior, which never lost its wild fish completely, northern Lake Huron, beginning to pop up a little bit in Lake Michigan. But again, this question of why does it take so long? Why is it so hard? And a lot of what we did is we said, now we've got success, we can start doing things like comparing what's different between a stocked fish and a wild fish. What is a wild fish doing that suddenly it's successful? Is it just being like a stocked fish, or is it different? So we looked at diet, for example. What are these little ones eating that might give us a clue to, oh, there's a new forage base available to the little ones. What is their diet? And then do that with the adults and look at their diet. Where are the fish? Are the wild fish and the stocked fish in different places in the lake, either in depth or north to south? And we started just describing the differences in behavior and foraging and distribution between the two types of fish. And then also wounding rates, because we've always thought the agencies together and the university, is it possible that sea lamprey have been the obstacle, and sea lamprey is now being suppressed? They're a parasite predator of lake trout. Is it possible that they were suppressing lake trout? Now the U.S. Fish and Wildlife Service has suppressed sea lamprey. Maybe that was the secret. And certainly the wild fish seem to have slightly lower wounding rates than the stocked fish, almost indiscernible. Uh, is that a clue to why now we're doing better with the wild fish, now that the lamprey are well suppressed?
There were a couple of things, from your research that sort of really struck me when I was doing, reporting on this. And, alewives, this invasive fish, that's sort of an ocean fish, came in, I don't know, maybe 10 or 15 years before you guys started to see these wild fish. And it has really sort of upended the forage base and is now, sort of the number one fish.
Yeah,
You talk about the work that you guys did, in the
yeah.
Great Lakes. There's this idea that alewives have been, a major detriment to lake trout. They can prey on the eggs, and they, might be screwing with the plankton populations. Here, you guys maybe sort of theorize it might be having a different effect. Talk about that.
So, yeah, alewife have been assumed to be the scourge of the Great Lakes. They're responsible of outcompeting a lot of native species, the ciscos and their relatives, the lake herrings, what used to be called lake herring. As you say, they eat lake trout directly. They also have this sort of slightly fiendish attribute. It's evolution, right? That they contain an enzyme in their bodies that destroys vitamin B1, thiamine. So this enzyme is thiaminase. And many researchers have found that if you eat an animal that has thiaminase, if a lake trout eats a lot of alewife, then it destroys vitamin B. And the parent can keep eating other things that have vitamin B, like taking your vitamin pills, but they don't have enough vitamin B to put into the eggs. And when they hatch 6 months later and they start to develop, they need vitamin B1, and it kills them. So why are our fish suddenly surviving when we just added alewife and now they're doing well? That's completely contrary to what we expected. And we found a couple of things. One is that most of the work done on fry survival, these little guys, has been done in the hatchery. And in the hatchery, they feed them little pellets. Now you can feed them little vitamin B pellets when they feed, but they won't eat them until they get big enough to figure out that it's food. When they're very small, they want something moving, and you see them sort of tracking when they're very small. But the hatcheries don't feed them when they're very, very young. They let them just eat, live off their yolk sac, the maternal food that they're equipped with. We did some very early life experiments and found that, oh, in the wild, they're eating zooplankton really early, like 2 days after hatching or within a week of hatching. They're eating their vitamin pills. They're fine. And so that was one thing that's interesting. We never knew that before. Got to see whether that's also true in the upper Great Lakes. There's no reason why it wouldn't be. And then what you're referring specifically to is that we've got alewife as a new forage for the adult fish. And in fact, the juveniles are eating them by the time they're just over 1 year old, in their second full year. Alewife are herring, and herring are very fatty. And fat's what you want if you want to grow up and be strong as a fish. So it's entirely possible when we do a food web model, and this was a couple of postdocs who've worked with us, Justin Lesser and Rosalie Bruel, basically put together all the components of the food web of Lake Champlain and said, okay, what's it look like? How's it changed? What are the relationships here? And it turns out if you add sort of that energy component that comes with the lipids, that the fats that are in alewife, it's probably putting a big boost into lake trout energy and a big boost into what they can produce in terms of eggs. And those eggs now are better endowed with energy against storage. That might be the sort of smoking gun, the secret to what's been happening. It's a good hypothesis to work with.
Right. Now, back on the stocking. So, going back to the 70s and 80s, I think stocking was as high as like 170,000,
Yeah,
a year. And this year it's going to be down to like 40,000.
correct. Yep.
And for a while there was stocking from both New York, on the New York side and on the Vermont side, and they sort of were raising, their fish in a different way and stocking a different time of year. When the cooperative decided to cut back stocking, it sort of made sense as a logistical efficiency to just
Hmm.
get rid of New York's contribution. Just the math worked out. Talk a
Yes.
little bit about, the research that, you and, your postdocs have done into the genetic lineage of the wild fish that are surviving in the lake, sort of where they came from.
Well, so it's partly strain, which is the genetic lineage you're referring to, but it's also bigger than that because one of the things you do when you're stocking fish is ideally you do in the term we call it performance testing. Where is the best place to stock them so the gulls don't get them after you stock them? What's the best time of year to stock them? What's the best life stage? Do we stock them as, newly hatched? Well, they're awfully small. Do we stock them at the end of their first year when they're about this big? They're called age zero. Do we stock them in the spring? So you kind of experiment with this and you track who's surviving. And that's very hard to do, and it had not been done because hey, we've got a population of adult lake trout. What's the problem here? So if it's successful, don't ask questions. So what we did, and part of the problem too is you've got to then mark all the fish differently by when and where and who stocked it, etc. So what we did is we had a postdoc come in, Ben Marcy-Quay, who could do the genetic technique that says, I know I can look at the parents in the hatchery that provided these fish and identify where these fish came from. Were they stocked by Vermont? Were they stocked by New York? And I can identify, he can identify who produced the wild ones. Was it New York? Was it Vermont, etc.? So briefly, New York stocks in, I'm going to get this right. New York stocks in spring. I get this backwards sometimes when I'm not thinking, right? They stock on the New York side and they stock Seneca strain and they stock them at age 1. Vermont is stocking in the fall at age 0, and they're stocking what we call a Lake Champlain strain, and that's an amalgam of everything that's been put in the lake. Multiple strains were put in earlier, so there's sort of a bit of a mixture, but largely Seneca strain coming from Seneca Lake in the Finger Lakes in New York. And so what Ben found is we got much better survival of fish being put in the lake by New York, disproportionate to the number that was stocked. They stock a third, Vermont stocks two-thirds until the cutting, and way more fish were from New York. We know Seneca strain survives a little better. They seem to have some resilience in the face of sea lamprey. But the other big piece, and it gets more complicated, but there's sort of a side opportunistic experiment that was done, is it's also that they survived that extra period in the hatchery where they're nice and safe over the winter. You stock them in the spring, life's good, they go feed and start growing. If you stock them in the fall, they've got that harsh winter to get through and just time. That's an extra 6 months in the lake when they're very vulnerable. And they die. A lot of them die. And that may explain a great deal of the difference between these two strategies.
Right.
As you say, New York needed they had an issue with their water supply. They said, could we just not stock this year? Great, natural experiment. Don't stock. We'll cut stocking, see how it looks. And that's why we dropped it by a third.
Right. And as you know, I mean, and I visited the Ed Weed hatchery where
Yeah.
they're, now all of the fish that go, all the trout that go into Lake Champlain are raised. They're in two concrete raceways there. I saw them. There's, 40,000 of them that are getting raised. And they're now, Vermont is stocking both in the fall, they'll stock half of them, and in the spring. And they're trying to sort of work out, whether or not one of those is a better way to do it. So, eh, in your mind, is the goal when it comes to stocking to get to a place where we don't have to stock at all? And if so, like what will the researchers, the managers be looking for to sort of feel comfortable that we can do that?
Um, so they're looking for two things. First, they already reduced stocking a second time. We're now down to, it used to be 84,000. It was about 100 and about twice that early on when sea lamprey control took effect. They said, whoa, survival is going to be a lot higher. They cut it down to 85. Then they cut it down a third, and now it's down to 40, as you say. So a half of what it was a few years ago. Um, what are they looking for? The first is there's a great deal of concern for the anglers. Anglers like getting lake trout, and the state is serving two populations. They're serving the fish population and protecting and enhancing it, but they're also serving the anglers. What do you want? We want to be sure you've got the fish you want to fish for. So there was concern that anglers would not appreciate less lake trout. So they wanted to be sure we'll still have plenty of lake trout and anglers will have what they want. And the response of anglers has been tremendous. People understand why wild lake trout are of value, and they're also, honestly, and the anglers say this as well as we do on the deck, they're beautiful fish. They're much more handsome than the hatchery fish are. So that's one piece. The biggest concern is that, again, we overstock, that the stocking, which is not responding. I mean, the wild population, if there's too little food, they either won't grow up or they won't produce as many young, or the young won't survive as well because they weren't well endowed as eggs with fats. So they're responsive, and so they'll produce less offspring. And then you just keep dumping another 40,000 on top of them from the hatchery, that regardless, and that might be a problem. So we also want to know, and this has always been a question, it's a very hard one to answer. Is it possible that the stocking is actually suppressing the wild reproduction? If we stop, do they take off? In every other lake where, Lake Huron, Lake Superior, where they stopped, the wild population took off. But is it coincidental or is it cause and effect? That's a very hard thing to prove. We'd have to stop stocking and then start stocking again, and then and that takes decades. But it is interesting that as stocking has slowed, we've continued to get lots of wild fish. So it's not a concern that suddenly there wouldn't be enough fish because we weren't stocking them and somehow the wild population declined. Wild population's doing great. The discussions are certainly out there now. When do we stop?
Yeah. And I know the managers are, they're looking at different metrics to account for these stocking reductions. And, it's going to be, they say, that because these fish live for 30 years and take a while to become, sexually mature, like you really need to give time to these reductions to sort of work their way through and to understand them. So it's going to be, at least a few years before any kind of more, but you're retired or almost retired, like, do you think we could cut stocking to zero, tomorrow and see a healthy lake trout population in the lake?
The thing that reassures me that it's, if the managers decide to do that, that it's a good decision, and it's entirely a management decision. I'm just the researcher who says, this is what I see, this is what I find out. They take that knowledge. But in addition to sort of having a good, strong population that continues to be more and more wild fish, you want to have enough mature fish. And so you don't want to say, oh, we've got the first year class of 6-year-olds. That's when they mature, 5 or 6 years old. Great, let's stop stocking. Because now everything's dependent upon that 1 year class for a year to start the next generation and the next generation. So what you really want is to have 5 or 6 or 7 ages, year classes, as we call it, of reproductively mature fish. And we're getting close to that point. So everything looks good to make a decision like that. I mean, I'll put it the other way. It would not make me at all nervous if they said, yeah, maybe we should stop stocking. This population, the wild population, seems extremely robust.
Yeah. And after decades and decades and decades of having this lake trout population propped up by, fish we're raising in hatcheries, feeding, pellet food or whatever, like what
Yeah.
would it mean to you to like, the ecosystem to have, a wild lake trout population sustaining itself without, our hand?
Well, if you sort of step back and think about it, we've been paying to have the ecosystem balanced with its native top predator and to have anglers enjoy that resource by angling them out of the lake. So for every fish that an angler pulls out of the lake, the hatcheries put, tens of dollars into putting it in the lake. Well, it seems a bad way to run an ecosystem when you could have it for free. It's supposed to be self-sustaining. So it just takes care of itself. At the same time, of course, the management's doing a huge amount of work on assessment and gill netting and checking the forage base, etc., to make sure they're okay and you can fish for them. It used to be free, all of that. Now, we've changed the system a lot. We're always going to have to watch out to see how alewife are doing and are the native smelt collapsing. But at least the lake trout could be doing it on their own the way they should. That's
Right.
deeply satisfying. And of course, balancing the food web is very important.
Okay, so yeah, I'd like to go to some questions. I've got a couple questions here that people typed into the Q&A. If you have other questions, add them or raise your hand, and I can hopefully, let you ask your own question. So, as you think up a question and you have one, raise your hand. Lewis here asked, why do lake trout seem to live in deeper water over shallower water? What are the biological reasons for this? Are they able to live where there's, lower oxygen in that deeper water? Talk about sort of where in
Sure.
the lake they like to be and why.
So the answer is yes and no. So like all fish in fresh water, we can basically say they're either warm water fish, cool water fish, or cold water fish, meaning that they are biologically adapted to a temperature range. And lake trout are a cold water fish. They have to be below their optimal temperature is about 16 centigrade, which is now I have to translate, right? About 65, right? Somewhere in there. Um, they will die if they get much warmer. So when the lake starts to set up with a warm zone and a cold zone, an epilimnion, hyperlimnion, if they go into the epilimnion for long, they'll stress and they will die. So deep is where the cold water is when the lake is stratified into temperatures. So the oxygen thing is important. If you're a cold water fish, you want lots of oxygen. And they go together. Cold water has more oxygen in it unless it's being depleted by eutrophication problems with pollution, organic pollution. We don't find lake trout in the inland sea in Mallett's Bay in the summer because there is a cold water zone. It's not great because there's a lot of warm water. They're shallow, relatively shallow basins, but there's so much eutrophication, relatively speaking, to the main lake that that layer at the bottom where the cold water is also becoming low in oxygen. It has biological oxygen demand. Lake trout in there are going to either they get squeezed by too hot above and too little oxygen below, and that layer that they can inhabit gets smaller and smaller. In the main lake, they don't have that problem. There's not a hypoxic or a low oxygen area at the bottom. They've got lots of territory in cold water to move around in. In the winter, they can get into Mallett's Bay and the inland sea and have a good time because they've got a lot of cold water.
Right. Now, Mike here says, thank you so much, Dr. Marsden. Says, blessed to have you on Team Champlain. And he's wondering what kind of upcoming research into lake trout are you most excited about? Is there anything, and then also, I guess relatedly, is there anything about the lake trout fishery that keeps you up at night? I guess what are the sort of risks or threats that are still out there?
We're really blessed in Lake Champlain in a number of ways. Great agencies and teams and collaborators to work with. Great angling population. Eh, People who understand these fish. Who I mean, I'm sure there's bad players somewhere, but every angler I talk to understands, as I say, the importance of wow, wild lake trout are a good thing. That wasn't always the case, and there was a manager years ago who thought, no, we don't want wild lake trout. We want to be able to control everything that happens in the lake. Again, expensive way to run a system. What do I worry about? The worry right now is when anglers and then also the state agencies catching the adults start reporting thin lake trout. what we call lake trout with poor condition. They're not heavy for their length or heavy enough. And that says, okay, are they not getting enough to eat? If they're not getting enough to eat, that means there's not enough smelt and alewife. Is that a sign that we have too many lake trout? And again, it's going to be very hard to address that. I mean, you can stop stocking, but there could be a period when the forage base and the number of lake trout are a bit out of sync. It presumably, ultimately, it will balance or fluctuate. But that's the one that would keep me up at night, is do we understand the forage base well enough?
Yeah. And Bill is asking a sort of similar question. He says he's caught lots of lake trout this summer, so good for Bill. But also, he's saying that they seem to have their fins cut and they're skinny. Why might that be? Are the lake trout healthy? Like what is the showing up in the data about sort of the condition and the health of these fish?
The data that recently is showing that condition does seem to have gone down a bit. And again, everybody, the state agencies, the feds, the people who are collecting these data, we all meet about 2 or 3 times a year and go, all right, what's going on here? At UVM, at the university, we're in the middle of trying to revitalize a forage fish survey. The states, particularly Vermont, did a forage fish survey for 30 years, just keeping track. Is everything looking good? Are there plenty of smelt? And there weren't alewife at that point. And unfortunately, they canceled the survey the same year we started finding natural reproduction in 2015. And because of a number of factors, trying to get a project up to speed, and then COVID hit, and then UVM didn't have a boat for a while. We haven't really been able to get going starting a new survey until last year. So we've got our first year of data, and that doesn't mean anything. Just like, yep, this is how many fish we got. You need multiple years to say, is the forage base going up? Is it going down? How healthy is it? Are the smelt and alewife in good condition? So there's a lot to be done to understand why those fish are thin. Is it not enough forage? Is the forage not eating enough? Are they not fatty enough? Or is it something else?
Right. And I went out with you guys in the spring,
Yeah.
as you were getting that forward. I mean, talk a little bit more about that study and what, specifically how it works, what you guys are looking at. There you're collecting samples and weighing them and freezing them and coming up with sort of relationships so that you can do a sample somewhere and then determine what that might, extrapolate out to, more broadly. And I know there's also sort of like ways to look at the forage base through like sonar, where you're just kind of
Yep.
looking at big clumps. I mean, these methods are really fascinating. Talk a little bit about some of the ways that you all are trying to understand the forage population.
Well, the first thing to understand when you're trying to understand a population of fish is, rather literally, it's all relative. There's a great quote about fish. They said, counting fish is just like counting trees, except they're invisible and they keep moving around. In other words, you can't count all of them. You have to basically take a sample, you know how much effort you put into getting that sample, and then you have what we call a catch per unit effort. So say, great, I got 50 lake trout per 1 minute trawl. It tells me nothing. If in 10 years I'm still getting 50, I know the population's stable. If in 10 years I'm getting 500 per 1 minute trawl, I know the population's gone up. So you have to do it on a relative basis. So that's why I'm saying this 1 year will not get us anything. We're going to be doing it again this fall. We'll do it again next spring and start collecting annual data. So there's absolute numbers. Then it's where are they? So we're looking in the southern part of the main lake, central main lake, north main lake, Mallett's Bay, Inland Sea. So we're looking at all segments of the lake. Is it staying the same, or is it fluctuating in different ways in different places? Because we know the wild lake trout are not evenly distributed throughout the lake. Surprisingly, there's more in the central lake, less in the north lake, etc. And then the fish themselves, the forage fish, we have to ask how, as I said, how well are they doing? How fat are they? What's their condition? How many age classes of smelt are there? We could get lots of smelt, but if they're all 2-year-olds, we've got a problem. Again, we need multiple age classes to support a population that's healthy. Um, I mentioned the diet study we did for adult lake trout. What do adult lake trout want to eat? When alewife came in, we said, are they going to switch to alewife? Are they going to ignore the alewife? And so we keep characterizing what do they need? What are they looking for? And then we balance that with what we're seeing with the forage population and part of that food web model. So all of these elements go into a forage fish survey.
Yeah. And how long could it take before you think you guys have a good handle on the forage fish population?
I mean, I'd love 10 years of data, but by the time, I mean, I wouldn't want to draw any conclusions about anything until we're getting to 3 to 4 to 5 years. It's very scary to make a decision based on, say, 3 years of data and say, oh, there's a lot more fish in year three. Great, we could stock again. That wouldn't happen. But that's it's too. There's normal fluctuations in any population. That's just what you expect. So you want to draw conclusions on a pretty solid timeline of data.
Right. And Mike is asking, is there anything about lake trout behavior that anglers may not be aware of or be surprised by, or, that we're looking for the insight here.
Well, so the most recent doctoral student who finished his dissertation in July, and some of the anglers know him, Matt Fuchsia, is now working with me actually as a postdoc. He tagged fish and followed them around. So these are acoustic tags that are in the belly of a fish. I should mention that other acoustic survey you asked about. But with this kind of acoustic telemetry, they've got a tag, they're beeping their location is being picked up by passive receivers we've got throughout the lake. And that sort of technology has taught us a huge amount about, for example, what depth I mentioned earlier, lake trout are hanging out at. We normally find them near the bottom, within, say, a couple of meters, 6 or 7 feet from the bottom, which is why we can catch them with a trawl. But the bottom can be at any depth. And it turns out that the depth of the wild fish is slightly different than that of the depth of the stocked fish. The wild fish often are a little bit deeper. So that's interesting, that those changes in behavior. When we get in other lakes and other studies, I've done this also in Lake Huron, other people are doing it in the other lakes. We think of lake trout sort of doodling along in the bottom and the deeps. And then if you've got the right kind of tag, which can give you depth, you'll suddenly find them like shooting up into the epimlemnion and then shooting back down again. It's like, what was all that about? We see this in small lakes particularly, and it appears what they're doing is they're going up into the warm water and grabbing a fish in the littoral zone, the nearshore zone. It's nice and tasty stuff up there, and going down before they get too hot. So they're finding, for example, in a small lake in Quebec, they're finding lake trout with bluegills in their stomach or salamanders. It's like, oh, okay, not what you'd expect of a deep water fish. And we can see these behaviors in the stomachs if you kill them, but we can also see them with the acoustic tags.
Right. Now, how deep will they go? And it's sort of seasonal, like in the earlier, and as it gets warmer, they go deeper, and the lake is 400 feet deep. How deep might we find
They
lake
could go
trout?
all the way to the bottom. There are other strains, other types of lake trout. In actually they're morphs. They're different. They look different in the Great Lakes. So there's ours are called leans. The most remarkable one is called a siskiyate. It's called a fat. I mean, it looks like a football, and they're about 48% fat content. I mean, 48% of the body is just fat. And those fish can go, well, I don't know whether they've been seen really at the entire bottom of Lake Superior, that's 1,600 feet deep, but they certainly go, to close to 900 to 1,000. So they are very much a deep water fish. They don't use their gas bladder as much. The anglers who know about overinflating a fish that has been pulled up from depth, its gas bladder expands. The deep water fish, the siskiyate, doesn't bother with the gas bladder. Those lipids keep it buoyant the right way, and lipids don't change in density as you go up and down.
Right. And there is a way to sort of age, and there are different methods to age these fish. You can cut their jaw bones and,
Yes.
count like tree rings or something. What are some of the older lake trout you've found, and how big have you seen them? I mean, what are sort of the upper limits of what we might find out there?
Okay, we're going to get into bragging rights here, right? It was no, wait, okay. Um, we've certainly seen them close to 950, I think sorry, we work in millimeters, so we'll have to translate backwards into that. 3 foot?
Hmm.
Um, the normal method for aging fish, as you say, is to take its ear bone out. You have to kill it, and look at the rings like as on a tree. They're annual rings, very much like a tree. The ear bone in a lake trout is tiny. It varies by species. A drum has a huge, great ear bone. For their size, lake trout have a little tiny one, so it's hard to work with. Recently, a colleague in the Great Lakes worked out that you can take the maxillary, it's a bone just above the upper jaw. It's very obvious, it sort of sticks out. And you can take that off. You can actually take it off non-lethally without killing the fish. It's painful, but you can. And that's got a lot of, you can take a lot of sections of it and look at the rings. And so we worked on that in Lake Champlain, said, yeah, this is a great method. The oldest fish we saw was 33. And that's not unique. We've seen a 32-year-old. We've seen some pretty nice old fish.
Right. And I think Lewis is sort of asking about, do these stocked fish, will they live sort of, do they have the same lifespan as a wild fish, a native fish? I mean, will they live to be 30 plus years old? And,
Absolutely.
they sort of fill out the same way that we would expect these wild fish to do.
Exactly right. There's nothing to stop a stocked fish. They're not any less healthy in terms of the potential for longevity.
Yeah. And Bill is saying, and I appreciate all the angler wisdom that is coming
Oh,
into
that's
the
it's
questions
great.
here. He's saying they haven't seen as many lake trout in shallow water in the spring as there used to be, finding them down deep earlier in the spring than in the past. Says he hears this is because of a different strain of lake trout. Do you know anything about, what might be why they may be going deeper earlier in the spring?
Right. The there has not been a change in the strains. As I said, in the early years, they were stocking everything they could get their hands on from Lake Superior and Adirondack Lakes and Seneca Lake and so forth. And then they settled down on just taking eggs from the fish that had survived in the lake and calling this the Lake Champlain strain, the combination, and then stocking some pure Seneca strain. But that has not changed in the last 15, 20 years. So it's not a strain thing, though. That would be a logical potential if we were stocking different ones. Um, Troublesome, of course, is it's likely related to the epilimnion being warmer and being deeper. As we get global warming and it gets warmer and warmer, we just get more warm water stacking, and the lake trout have to get below it. And it may be they're sort of instead of just pushing down as low as the thermocline, they may be even going into deeper water.
Yeah.
A more troublesome possibility is what if the prey is not as abundant and they're having to go deeper than they wanted to find it.
Now there's something like 70, give or take Adirondack lakes that have lake trout in them. Some are, native populations. They're not stocked and they're doing good. Some are stocked, some are mixed. These lakes are smaller, some aren't as deep as Lake Champlain. They're also warming. Do you think that the Lake Champlain is going to be more resilient to climate change because of its size and depth going forward?
Depth is the key, absolutely. You've got to have that sort of thermal mass, that volume of water that's so big that there's not enough, it won't heat up. There's a lot of it below the thermocline. So yeah, there's what we call a refugium in Lake Champlain of a lot of deep cold water. Adirondack lakes, the ones that are very deep, they've got a small surface area for their depth. It's somewhat protected because there's just limited sunlight that can warm the water. But as that warm water fills in and gets deeper, it will really stress these cold water fish.
Yeah, we're really seeing that, especially a lot of research in brook trout lakes, where
Yes,
they're having this oxythermal, squeeze
stress. Yeah,
happening.
yeah,
Yeah.
absolutely.
So Mike is asking, do lake trout, are they, when they're cruising and hunting, are they doing this in pairs or groups, or are they more sort of solitary?
This is a solitary hunter. I mean, you sometimes found that there might be a group, on the sonar you might see more than one. And that's probably likely because there's a school of alewife or something in there and they've all sort of in common found it, but they don't hunt in teams. In the fall, when they start to spawn, Of course, now on sonar, you'll start to see them aggregate and you'll see the echoes going, okay, now we've got a spawning area and you're seeing lots of them all in one place. And they will do something when we can see them on camera, they'll do something called pair swimming. But this isn't about eating, this is about something completely different that's much more important. And so they're swimming together. And I see if I can get my hands doing that. And it's a male basically trying to keep with the female and court her. And we're trying to develop this image, this understanding of how does a female select who she wants to mate with? Because lake trout have these really rich eggs. It's a resource, right? She doesn't want to just give that away to just any partner. She's going to be selective about getting a sexy male. And so how does she select? And it appears, the guess is at this point from the videos is that a male will come in and swim with her. And if she doesn't like him, she just keeps swimming until he gives up. And just, okay, right, well, whatever. A male comes in that she likes, they'll pair swim for a little bit and they'll drop towards the bottom. And it's her, sort of starting that drop. They drop to the bottom and she'll do a spawning event. She'll squeeze out, a few hundred eggs. He'll get to fertilize them. And then they might do it again and again and again. Or she'll wait till the following night and do it again with another few males. Uh, but that's the pair swimming that you see.
Yeah. I'll have to get into the courting ritual more in my
Yeah.
follow-ups. Yeah.
Oh yeah, there you go. It's
So
one of the hot
Mike,
topics right now.
yeah,
Yeah.
Mike definitely wins the, I think, furthest away award. He says that he's watching this from McMurdo Station in Antarctica right now.
Awesome.
So
Wow.
that's very neat, Mike. I appreciate you sharing that with us, and I hope you're
Welcome.
staying
Wow.
warm and
Uh,
learning some interesting things down there, up there.
Gosh. I think
Uh,
you should come on and start talking about what's going on in McMurdo.
yeah, really. Well, the next Zoom will be with Mike for sure.
Excellent.
Lewis is asking if there's any evidence that you know of to support acid rain effects on the lake trout population, the Adirondacks, or in Lake Champlain. I mean, this obviously acid rain has had an enormous impact on, lakes throughout the region. Do we know if they, might have affected lake trout at all?
Certainly, the canary in the coal mine, if you will, for acid rain in the Adirondacks is the brook trout, because they're up, in waters that are, tending to be a little bit more affected. And it can affect them either way. When they're very small, they're very vulnerable. It's a dilution, it's a dose response thing. The small body mass, a lot of effect. And the other problem is just their food. If it affects their food, then they go hungry. I confess I don't know about effects on, I mean, the effects on lake trout are not so well studied that I've heard a lot about this. At the same time, I've not done a lot of research on the Adirondack Lakes to
Right.
know to what extent.
Yeah. So a couple people have asked about, whether or not there'll be a recording of this. There should be a recording. We'll have that on the Adirondack Explorers YouTube in the next few days, and we'll probably post a story next week sometime with it as well. And it's possible that we might be able to just email that out to people who have registered here. So, just for sort of to wrap things up, native trout restorations are really sort of native fish restorations of any kind, they don't always have this kind of, more positive narrative arc to them. So what do you think has gone right in Lake Champlain? And what lessons might we, take from, this lake trout revival in Lake Champlain that could inform, other native trout restorations or really, other native fish restoration efforts, anywhere?
Right. Well, doing those in the reverse order which you asked them is, I think one of the take-home lessons is don't give up. Right? The Great Lakes folks have been trying this for 60 years, and sometimes you're thinking, wow, should we just survive just on these stocked lake trout? And the fact that we can have this remarkable success story incredibly quickly. I mean, we were sort of from 0 to 60 in 6 years, making this clear progress towards success, and now probably at success, maybe stop stocking. It's very encouraging. We can undo the damage. We can actually heal some of the problem that was caused. So that's just a great optimistic, take home. We're starting to say, well, maybe alewife are not necessarily the reason for not being able to restore them, and maybe in fact they're helping to restore them, which again is very controversial. That's bizarre. But the thiamine problem that the Great Lakes has been saying was the doomsday story does not appear to play out here, because we have restoration happening. Sea lamprey, right? Wow, suppression of sea lamprey certainly played a role in this. And that's incredibly encouraging. What's interesting too is that the sea lamprey here, even though suppression has been done really well by the feds, our goal, our sort of threshold, how do we know when we've got enough suppression of sea lamprey? We do it by how many wounds there are and lake trout. In the Great Lakes, their wounding level to say, that's where we want to be, is 5 wounds per 100 lake trout. Our threshold is 25 wounds per 100 lake trout, and we've never achieved it. Well, that's not true. We just bumped into it one year. So at 5 times higher wounding than in the Great Lakes, we still got lake trout restoration. So that says we could either our lamprey are a bit smaller, we know they are, or not doing as much damage, or they're not quite as big as a problem that we thought. We can restore lake trout even in the face of that kind of wounding. And then the rest is, we got to keep looking for additional answers.
Right. If you were able to go back and, tell yourself in the, mid 90s, the late 90s, everything you've learned since then and what you've seen with this revival, do you think you would be surprised by how far it's come, how fast it's come?
I'm surprised now that it's come so fast. I mean, it's been a really incredible ride to go from 2015, where before we started trawling, there was nothing, to here we are with the states cutting stocking and thinking about continuing to cut stocking. And just, you know, anglers and the state gill netting and us with the trawl, it's just wild lake trout after wild lake trout in the gear and going, this is great.
Right. And I asked you sort of what would you ask the lake trout if you could talk to them somehow? And I think you said, why now? I'm guessing
Yeah, exactly.
I'm
Right.
guessing you haven't had that conversation with the lake trout yet, but it's still sort of a mystery, right? Like,
Yeah.
why has it happened?
I mean, we wish we had nice, clean answers. You go, oh, that was it. And there is a tendency in science as well as other walks of life to look for the silver bullet. Oh, that was what the problem was. And the reality is, especially in biology, there is no one silver bullet. It's probably something to do with alewife as a food source and all those fatty, and something to do with lamprey control, and something to do with our zooplankton. We have a rich mysis population. These are the opossum shrimp, and that's what the little age zero, newly 6-week-old plus lake trout are sustaining. Their stomachs are full of those things. Do we have better mysis, more mysis than the Great Lakes? That could be leading into it. So it's lots of elements that we have to combine to say that's what made for success.
Right. Awesome. Great. Well, thanks so much, Dr. Marsden. Thanks to everyone who joined us. Great questions, a great conversation. At the Adirondack Explorer, we will continue to focus on lake trout all throughout the Adirondack Park, to focus on what's going on in Lake Champlain. And we definitely hope to do more events like this to, sort of share what we've been learning. I appreciate everyone, and we can wrap it there. So thanks so much.
And great questions from the audience. Thanks so much.
Yeah, I appreciate it. So, all righty. Well, everyone, have a great evening, and happy fishing out there, and happy research out there, and stay safe in Antarctica, and
Yes,
be well. Thank you.
you well indeed. Good fishing.
All right. Have a good night.
Thank you, Zach.